and welcome back to another video on Double A Learning. Today we're gonna stay with integration rules, and we're gonna stay with the integration world, but focus on integration rules. In our last video, we mentioned about Riemann sums, so if you guys haven't checked that out, make sure you check it out before this video, because we go into, in that previous video, we explain about what integration is basically. But just as a quick rundown, integration basically helps us find the area under the curve. I can sketch that out to make it more visible to you guys. Let's just say we have a graph like this from points here to here. What integrals allow us to do is just find the area in between those 2 points. Okay. In our previous video, we mentioned about Riemann sums, and Riemann sums basically allowed us to approximate that area. But with integration rules, we can find that exact value basically. And before I get into some basic rules, I want you guys to know there's a difference between some of the integration, different integrations. There's a definite integral and an indefinite integral. So a definite integral would be written like this and have some values like that, and then the function, which I'm just going to write as f of x, followed by a dx. Okay, so this right here is called the upper bound, and this right here is called the lower bound. Usually, this is what we would use to find the exact points of the area under the curve. So I can draw that graph again. Let's say this point x is equal to 0 and x is equal to 5. We would write 0 and then 5 in these blanks, and then whatever function this is, we would write that down, then take the integral, and then we would plug in these points to find that area under the curve. But the ones that I'll be focusing mainly on this video would be the indefinite integral. And those are simply just written like that as a normal integration, followed by f of x dx. Whenever you have integrals, you always have to include this dx. And then for indefinite integral, it basically goes on forever basically. We don't have any endpoint values that we have to say it strictly belongs in those areas. It doesn't really apply for this. So whenever we do have an indefinite integral, it is important you guys always add a plus c, because that plus c represents a constant. And when you're integrating, you're basically turning whatever function you had back to its original form. So an antiderivative basically. So there's always going to be some extra maybe possible constant there. So that's why we always add the plus c to symbolize that. Okay. Let's show some of the basic rules. Okay, so the first rule, it goes like this. If you have the integral of k f of x, you can simply rewrite that as k and the integral of f of x. And then don't forget the dx here and here. Okay, basically what this rule is saying, you can just move, if you have a constant value, just move it to the front here. It does the same thing. It's just kind of multiplying out towards the end, but I like to do this rule as more efficient, but yeah, this is a good rule to know. Alright, the next rule is the integral of f of x plus g of x, plus or minus g of x dx is equal to the integral of f of x dx plus or minus the integral of g of x dx. So what this rule basically tells us is that we can split it up basically, split these two into this form. It allows us to evaluate each integral one step at a time. Okay, let's do this part first and then the next part. Just again for clarity's sake, I think. So the third rule is the integral of 1 over x dx is equal to natural log of absolute value of x plus c. So whenever you see in this form, you guys always have to remember that it links to natural log. That's important to remember. Okay. Fourth rule, would be the integral of dx is equal to x plus c. And this rule makes sense, right? Because we know the integral is just an antiderivative. That's just another name for it. It's reversing the derivative. Okay, now the fifth rule is the integral power rule, I think it's called. So it'd be xn dx is equal to x n plus 1 all over x plus 1 plus c. Now, this looks, I remember when I first saw this, it was kind of confusing, but once you guys get into some examples, which I'll show later in the video, it'll make much more sense. So yeah. And the final rule, basic rule, that I think you guys should know is the integral of e to the x dx is equal to e to the x plus c. This is basically the same as derivatives. E to the power of x is, or the derivative is always e to the power of x, and then the integral of e to the x is always e to the x. So I just want to give you guys like a warning, quick warning before we go to the next part of the video. I'm not going to do trig integrals in this video. If you guys want to see a separate video on trig, let me know in the comments, and I'll probably make that my next video as well. Okay, now let's get into some examples. Okay, our first example I'll consider much more easier compared to others. Be the integral of, this is the indefinite integral because it's not defined in either points, of 3x squared plus 2x plus 1 dx. Okay, what I would do in this situation would divide all these parts up. What that means is I'll do the integral of 3x squared dx plus the integral of 2x dx plus the integral of 1 dx. This way we have smaller integral parts that are easier for us to find out. So for this one, what we have to use is the integral power rule. It's like basically the inverse of whatever we do for derivatives, but I can just show that for you guys right now. So let's just focus on this one right here, the integral of 3x squared. So what that rule told us was we had 3x squared. So what you have to do is add to the power so that 2 becomes a 3. Then you have to use this so that 3 goes in the bottom and you divide it by the whole thing. So these 3's will cancel, and this would be x to the power of 2 plus 1, which is equal to x cubed. And that makes sense, right? We can just double check it by taking the derivative of this. So if we took the derivative of x cubed, we can just move this 3 to the front. That just becomes 3x squared, and that gets us what we had here originally. So basically we can also check if our integral that we did, at least for like easy ones, is correct by just like undoing it kind of. So as of right now we have x cubed plus, okay, let's do the same thing for this one, the integral of 2x. So we have 2x. So remember, this is to a power of 1. So we can add the 1 here. So 1 plus 1 is 2. So in the bottom would be 2. And then we can cancel these 2's out. So this would be equal to x squared. So right here would be x squared. Now what about 1? 1, well, we know when we have constants, I could think, okay, how could we anti-derivatize that, basically? So if we had just x, we know the derivative of x would get us 1. So the integral of 1 would just give us x. So it's like an inverse kind of. You guys see that? So it'd be plus x. So our answer would be x cubed plus x squared plus x. But we wouldn't be done. We'd have to include the constant c. We can never forget this constant. If you guys like forget it, you most likely lose points on your quiz, test, or exam, or whatever you guys have. So it's important you guys remember that plus c. So our final answer for this integral would be this. Okay, let's go to a bit more challenging question. Okay, so this one is the integral of x plus 1 all over x squared plus 2x plus 1 dx. Okay, what will we have to do here? So, when you do integrals, you have to like kind of guess and check almost, because there's gonna be different ways you can solve for the integral, but there's gonna be some that are easier than the other. So just by looking at this problem, something like stands out to me. I see this term right here, x squared plus 2x plus 1. I noticed that we can factor that. So when we factor that, we can factor it into x plus 1 and then x plus 1. And we can double check our factoring just to be sure. So that would be x squared by doing the FOIL method. X squared plus x plus 1. So that becomes x squared plus 2x plus 1, which matches what we had right here. Okay, so we can simplify this into x plus 1 and x plus 1, or x plus 1 squared. So this integral, I'm just going to rewrite as x plus 1 all over x plus 1 squared dx. Okay, now what we can do, we can cancel these out because they're common terms. But there's a squared here, so it would be the integral of 1 over x plus 1 dx. Because it's a squared term, and this is just like a power to the 1 basically. Okay, now this is simple. If we go back to our basic rules, we know that the integral of 1 over x is equal to the natural log of the absolute value of x plus c. So if we just compare these two forms right here, we can kind of see they're similar, because there's the 1 on top and the x value would be our x plus 1. So the answer to this question would be natural log of absolute value of x plus 1, close the absolute values, and don't forget the plus c. So that'd be our answer. And we always have to include the absolute values when we're doing the integral of a natural log, because the natural log function, it has like some requirements, and the absolute value is allowed to be positive. So yeah. Alright, moving on to our final example that we have. It's going to be a bit more harder and a like new topic where we might need to use our rules, but like it's going to be something a bit more new that I haven't gone over. So it's the integral of x times e to the x squared dx. Okay, so I'm going to teach you guys this new thing called u substitution. So basically what u substitution allows us to do is make our integral more simpler by plugging in like a separate value of u. So right now what we have is x times e to the x squared. So I see this power right here, and it's like kind of standing out to me because there's an x and a x squared. So what you want to do when doing u substitution is always write this in your like, test or exam. So let u equal x squared. Okay, we let u equal x squared. But now whenever you do u substitution, you always have to do derivatives to it. So you'd have to write du over dx is equal to 2x. Okay, we have this dx right here, so let's make that a du. So du is equal to 2x the dx. All I did was multiply this dx to this side. The reason, again, I let u equal x squared is because I noticed we have an x term right here and an x squared term. And when we took the derivative, and whenever we do u sub, we have to take the derivative of whatever value. And when we take the derivative of x squared, that gives us 2x. Now, we don't have a 2x, we just have an x here. So, what we can do is multiply like this. So, it would be x e to the x squared 2 dx. But, since we add this 2, we have to add this 1/2, because what this is doing is basically making it so that this 2x here matches, so that we can replace this dx with a du. So this would multiply with this, but we can't just multiply a 2 randomly. We can multiply by 1 though, because that doesn't change the equation. That's the reason we have that 1/2 in the front. We don't want to alter this equation. We want to keep it the same. So yeah. So now that we have this, we can simplify it as the integral of the 1/2 the integral of e to the u du, because we know du is equal to 2x dx. There's a 2x dx here, so those would basically cancel out almost. So it would be 1/2 the integral of e to the u du. So if we remember from our basic rules, the integral of e to the x dx is equal to e to the x plus c. Okay, now we know the integral of e to the u is just e to the u, but we need to remember this 1/2 is still here in the front, because that 1/2 is being multiplied. It's basically like this, multiplying whatever the integral of this becomes. Now, we can't just leave this as our final answer. Let's sub back in whatever we had for u, because we were originally trying to solve for x. So we had let u equal x squared. So this would become 1/2 e to the x squared followed by the plus c. So that would be your final answer. The u sub can be a bit more challenging of a topic, but I feel like once you guys get enough practice and exposure to u sub, it becomes more understanding. So I included a practice sheet, like always, it'll be in the comments, and as easy, medium, hard questions that you guys can practice. So yeah, if you guys like this video, give it a like, and thank you so much.